Hello and welcome to our lesson on solving radical equations. This is going to be from section 6.6 in our text. Here I've got the 4 steps that I want you to go through when you're solving radical equations. The very first step, you need to isolate the radical. That means you need to get the square root or cube root or whatever root stuff all by itself on one side. Then, step number 2, you're going to square both sides. Notice I have a little asterisk here. That's because the exponent that you use to raise both sides to is going to depend on the index of the radical. Most of the examples we're going to do in this lesson are square roots. So we're going to be squaring both sides. But if you have a cube root, then you would cube both sides, or a fourth root, you would raise both sides to the fourth power, so on and so forth. And then, once you square both sides, to get rid of the radical, you need to solve the resulting equation and check your solutions. The check your solutions part is not optional. You need to check your solutions every time. And that's it for the process. Now we need to put it into practice. So the first example we're going to look at here is number 1. We have the square root of 2x minus 3 equals 4. If I follow my steps, first I need to isolate the radical. And if I put parentheses around it, you can see that there's nothing outside those parentheses on the left-hand side. So that indicates that it is isolated. And since it's a square root, remember that means that it has an index of 2. Whatever the index is the power that you raise both sides to. So since our radical is a square root, we're going to square both sides. Now, the reason we square is because a square and a square root, it's like they undo each other. You could say they cancel each other out. And that's going to leave us 2x minus 3 equals 16. And then you need to solve the resulting equation. This is pretty easy this time. 2 steps and we're done. Bringing the 3 over gives us 19, and divide by 2. That's going to give us x is 19 halves. Now 19 halves is not going to divide evenly, so let's leave it f'd up. Let's leave it fractioned up. I like it improper. And now for the check part. Remember I said the check is not optional. So we're going to need to check to make sure this is a valid solution. Plugging that back into the original problem, that's going to be 2 times. Here we're going to replace x with 19 halves minus 3 equals 4. And the 2's are going to cancel, leaving 19 minus 3, which is 16. And the square root of 16 is 4. So that checks out. And you can see that it doesn't take all that much work to check here. But it is necessary. And that's going to do it for our first example. All right, for our next example, number 3, here we have square root of 6x plus 1 equals 8. If I put parentheses around the square root part, you can see that there is an additional term that I'm going to need to get rid of in order to isolate the radical. So here the first step is to bring the plus 1 over. That makes it minus 1. And do you see that's going to isolate the radical? 8 minus 1 is 7. And then again, since this is a square root, we're going to square both sides, and the square and the square root cancel. So that'll leave us 6x equals 49. And then I'm going to solve the resulting equation. Divide both sides by 6. Again, this does not divide nicely. and it won't reduce. So that is our answer in simplest form. And then we need to check that solution. All right, so here we go. Square root of 6 times 49/6 plus 1 equals 8. It is important to note that you have to plug back into the original equation to check. Here, the 6's are going to cancel, leaving a square root of 49, which is 7. And I believe 7 plus 1 is 8. And so that checks out. All right, next for a trick question. Number 11, we've got the square root of x plus 2 equals -4. Here we can see the square root is isolated, but I want to point out that this square root is equal to a negative number. And since square roots always produce positive outcomes, then this is going to be no solution because a square root cannot equal a negative number. Now, that's not true for cube roots. Cube roots and fifth roots and seventh roots, as long as the index is an odd number, you can have a negative outcome. But when the index is even and it equals a negative number, that's going to always be no solution. Next, number 13, I thought it would be nice to look at least one radical equation that wasn't a square root. So we're going to look at, this time, cube root of x plus 5 equals 2. And the steps are the same. Here we need to isolate the radical. Putting parentheses around it shows us that it is all by itself on one side. Then, in order to get rid of a cube root, you have to cube it. Whatever the index is, the exponent has to match for them to cancel out. But I have to cube both sides, and that's going to leave me x plus 5 equals 8. 2 cubed is 8. And then I need to solve the resulting equation. Moving the 5 over, x is 3. And I still need to check, just for fun. I'm pretty sure this is going to be the answer, but we'll check and make sure. Here we have the cube root of, plugging in for x, that's going to be 3 plus 5 equals 2. Remember, going back to the original equation, 5 plus 3 is 8. And the cube root of 8 is 2. So that does check out. Next, number 15, I couldn't help but crank it up one more notch here. Let's look at a fourth root of y minus 3 equals 2. Here our index is 4. Again, the process is the same. We need to isolate the radical, which it is, and then whatever the index is, that is the exponent you have to use to get rid of it. So we're going to raise both sides to the fourth power. That's going to give us y minus 3 equals, OMG, what is 2 to the fourth? 2 times 2 times 2 times 2 makes 16. And then solve. Bringing the 3 over makes it a plus. Y equals 19. And then for the check, just to be sure, we've got the fourth root of, replacing the y with 19. 19 minus 3 is 16. And the fourth root of 16 is 2. And if you need to, what I want to do real quick is show you that the calculator can help you with this. To do a fourth root on my calculator, that's going to be Shift and the X to any power button. And then you get to fill in with a 4 for the index. So the fourth root of 16 is 2. So the calculator can verify these higher roots if you need help. All right, the next example, number 24, is going to be a little bit longer example than the ones we've looked at. In fact, I'm kind of getting excited about this one because I know what's coming. So we do have a square root equation. This is a radical equation where we need to isolate the radical first, which means the -2 needs to come over. And that's going to give us square root of 2x plus 7 equals a binomial. X plus 2, that's two terms. And now that the square root is isolated, I can square both sides. But look, you have to square the whole freaking side all at one time. The x plus 2 quantity squared, you cannot square each term separately. You have to do the whole side. Now the square and the square root are going to cancel, leaving us 2x plus 7. That's the easy part. On the other side, remember to square anything means to multiply by itself. And look at that. That's going to indicate the four-letter F word. OMG, we're going to have to F it up. Let's FOIL it. Here we go, bringing the 2x plus 7 down. And then first, x times x gives me x squared on the outside. I've got a plus 2x on the inside, another plus 2x. Last but not least, I've got a plus 4. Now, what I want to point out is, if you notice, can you sense the excitement in my voice? Woo! Now what we've done is we've gone from a radical equation to a quadratic equation. Holy cow, Batman. We're going to have to set this equation equal to 0. Remember, to solve a quadratic means you need to set it equal to 0. So I'm going to bring the 2x and the 7 over so that I can set this equal to 0. And I'm going to CLT on the fly. That means I'm going to combine like terms as I go. So when this 2x comes over, it's going to make a minus 2x, which is going to cancel one of those out and leave me a 2x. So I'm going to have my x squared plus 2x, and then the plus 7 becomes minus 7. 4 minus 7 is -3, definitely. And now that I've got my quadratic set equal to 0, this is now in standard form. And I'm feeling like doing the F word again, but this is the 6-letter F word. Do you know what the 6-letter F word is in math? Yeah, we're going to F it up. We're going to factor it up. You're going to have to know how to factor a trinomial. We've got our parentheses. We're going to read the signs. And we're going to fill in the blanks. X and x make x squared. Numbers that multiply to make 3 and subtract to make 2. That's going to be 3 minus 1. 3 minus 1 is a positive 2. 3 times -1 is -3. And now that I've F'd it up, factored it up, I can set each factor equal to 0 and solve. Man, did you notice we're going to end up with 2 solutions? Moving the 3 over, x is -3. Moving the 1 over, x is 1. So here we end up with 2 solutions. But don't forget the part where you have to check your solutions. So now for the check. And remember, you need to go back all the way back up to the original equation. So first, we're going to check the -3, plugging back in for x in the original equation. That's going to be 2 times -3 plus 7, all of that under the radical, minus 2 equals x, which we need to replace with -3. And then we need to work this out. So multiplication first. 2 times -3 is -6. Negative 6 plus 7 is 1. And let me go ahead and bring this stuff down. And then we're going to have the square root of 1, which is 1, minus 2 is negative 3. What? 1 minus 2 is not negative 3. And so the negative 3 solution is garbage. That does not check out. Now, let's see if the 1 is a solution. We need to check the 1. So plugging back into the original equation, that's going to give us 2 times 1 plus 7 minus 2 equals, and then remember that x right there gets replaced with the 1. So this is our checking our second answer. Square root of. Now, 2 times 1 is 2. 2 plus 7 is 9. Square root of 9 is 3. And 3 minus 2 is 1. And so that answer does check out. So you need to be careful in these problems where you end up with a quadratic equation. That's going to produce two solutions. And about 95% of the time, whichever one of those is the smaller number is trash. Sometimes they both work. Listen, sometimes neither one of them work. But you have to check your solutions and make sure you throw out the trash. All right, in our next example, number 29, again, here we have a little bit different setup. We have two radicals, two square roots in this equation. Notice that the square roots are isolated on both sides. So I can go ahead and square both sides. And what that'll do is that'll eliminate both radical symbols. Again, this is a special case where you're going to end up with just 3y plus 1 equals 2y plus 6. And really, if you think about it, the only way that two square roots can equal is if their radicands are equal. So we're going to set the radicands equal to each other, and we're going to solve for y. I'm going to bring the 2y over and bring the plus 1 back. 3y minus 2y, well, that's just y. And then plus 1 is going to become negative 1. 6 minus 1 is 5. And you still need to check your solution just to make sure. So plugging back into the original problem, 3 times 5 plus 1 should equal the square root of 2 times 5 plus 6. 3 times 5 is 15. 15 plus 1 is 16. 2 times 5 is 10. 10 plus 6 is 16. And the square root of 16 is 4, and that checks out. Last example, number 31. And I did save the best for last, okay? If I scroll up, and if you watched number 24, man, if you thought that was long and exciting, this one is going to be even better, okay? Notice that in this radical equation, which the radicals are square roots, I've got two radical symbols. In other words, I've got two terms that both have square roots, but then I have an additional term on the other side. So this is going to be different than number 29, where I had a square root equal a square root, and I could just get them both to cancel by squaring both sides. In number 31, if I move this square root over, it's going to have this additional term that's going to not allow me to square both sides and get both square roots to cancel. But I am going to have to move the square root of y over so that I can isolate this radical symbol. Remember, the first step to solve a radical equation says isolate the radical. So if you've got two of them with an additional term, you need to isolate one of them and then square both sides. So that's going to give me minus square root of y, 5 minus square root of y, which is a binomial. Okay, there's two terms. And now that I have this square root isolated, I can square and get rid of it, but I have to square this side. Remember, you have to square the whole freaking side. You can't square each one of those terms separately. You have to square it all at once. And what does it mean to square something? It means multiply by itself. And you know what's coming, don't you? It's the four-letter F word again. Curses, foiled again. We're going to have to F it up again. Here we go. Y minus 5 comes down. First, 5 times 5, 25. On the outside. Now be careful here. The coefficient of that radical is 1. And we're going to multiply the 5 times the coefficient of the radical. So 5 times negative 1 is negative 5 square root of y. That's how that works. And then on the inside, I have another one just like it. 5 square root of y. And last but not least, I've got a negative times a negative. That's going to give me a positive. And that's going to be square root of y times square root of y. Well, remember, anything times itself is that thing squared. But a square and a square root will cancel. So do you see that that's going to leave only y? So the square root of y times the square root of y is just y. Now, notice that I still have square roots in this equation. So this is still a radical equation. So now I'm going to need to repeat the process. Again, I'm going to need to isolate the radical, square both sides, and continue since I have square roots remaining. I told you this is exciting, right? Man, we still got a lot more work to do. Here we go. Bringing the 25 over and the plus y over. Hey, that's kind of cool. This plus y will make a minus y, and those y's will cancel. So those y's are going to cancel. The plus 25 becomes minus 25, which is going to give me minus 30 when I combine. And then combining these like terms, negative 5 square root of y, minus 5 square root of y, that's minus 10 square root of y. And then I can divide both sides by the coefficient of the radical. I'm going to divide both sides by negative 10. And that's going to give me positive 3. Well, this simplified nicely, actually, because now notice the radical is isolated and there's only a y underneath the radical. So if I square both sides to get rid of that remaining square root, that's going to be y by itself. And 3 squared is 9, and I'm done. Uh-oh, don't forget, we got to check it. And to check it, you got to go back all the way back to the original equation. So that's going to be square root of y minus 5. But our answer was 9. So that's going to be 9 minus 5 plus the square root of y, which is 9, equals 5. And now we need to check this for equality. 9 minus 5 is 4. The square root of 4 is 2. The square root of 9 is 3. And 2 plus 3 is 5. That does check out. So this is the solution. And that's going to do it for this lesson. So if you have any questions or comments about anything that I've done, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.